Rocket-powered sleds are used to test the human response to acceleration. If a rocket-powered sled is accelerated to a speed of 444 meters per second in 1.8 seconds, then what is the acceleration, and what is the distance in which the sled travels in that time? Now there's actually two questions here, right? But I'm going to start the same way. I'm going to draw a picture of what's happening. So there's a man on a sled here, and sometime later there's the man on the sled again, but in this case there's a lot of fire, right? He's moving very fast. What do I know about this? I know that velocity final equals 444 meters per second, and I know that velocity initial equals 0 meters per second. I know the time that it takes for this to happen is 1.8 seconds. So I know time equals 1.8 seconds. I know that velocity initial is 0. And I know that velocity final is 444 meters per second. But now there's two questions here. The first one is, what is the acceleration? And the second one is, what is the distance? So I'm going to simply run my guess here in the substitute and solve. First, the unknown is, what is the acceleration? So I'm going to identify the acceleration in the x, question mark, meters per second squared. My second experiment, or my second question, my unknown, is going to be displacement in the x. And that's going to be in meters. So for this one, the equation I'm going to use is going to be the acceleration equation. Acceleration equals velocity final minus velocity initial, all that over time. If I solve the numbers, my acceleration I don't know, but I do know velocity final is 444 minus 0, all of that divided by 1.8. And so my acceleration is going to be 444 divided by 1.8. When I do the math, my acceleration in the x equals 246.6666 meters per second squared. Okay, let's look at sig figs. I have 2 sig figs. I have 3 sig figs, so my answer is going to have 2 sig figs. And so if I significant figure it, I get 250 meters per second squared. And that's the answer to the first question. The second question, I get to use the same unknowns, but in this case I'm going to choose a different equation. My equation that I'm going to choose is velocity final initial plus velocity final, that quantity divided by 2, that's average velocity, and that equals displacement divided by time. So now if I replace numbers for letters, velocity initial is 0. plus velocity final is 444 meters per second. But I take that number and I divide by 2. And that equals, I don't know what displacement is, so I'm going to draw it again. This is displacement in the x, so I'm going to make it red. Divided by 1.8. If I solve the math on the right, I get 222 equals displacement in the x divided by 1.8. Now I can multiply the right side by 1.8, and I do that so that it cancels. But whatever I do to the right, I need to do the left as well. And when I do that math, I get displacement in the x equals 399.6 meters. But if I apply two significant figures, let's see, that 3 is significant, that 9 is significant, that 9 is not, so I get 400 meters.